All right, today we're going to dig into the practical reality of network access control, or what everyone calls NAC. We're going to break down exactly how modern networks actually enforce security, moving past the theory to what really works today in 2026.
You know, the network of 2026 looks nothing like it did even a decade ago. We've gone way beyond just having a bunch of managed laptops and servers. I mean, today's network includes everything you see here: IP cameras, industrial controllers, personal phones, cloud workloads, you name it. And here's the real kicker: most of these new devices just can't support traditional security agents.
And that brings us to the fundamental question that every single security team is wrestling with right now. It's pretty simple, but the consequences are huge. If you can't even identify a device, how in the world are you supposed to secure it?
So, first up, let's really get our heads around this new network environment and just how big this problem of unknowns has become.
This is where network access control comes in. A NAC system's whole job is to answer these questions, to identify every device, figure out its context, and then enforce the correct access policy.
Yeah, this slide really nails the shift. We went from that old castle and moat model, where we knew every device inside, to today's crazy web of interconnected systems. The key takeaway is right there on the screen. The majority of these new devices are unmanageable in the traditional sense. That's the new reality we have to design for.
So where do we even start? Well, it begins with the single most important rule in network security, which is our second section: visibility comes first. It's a simple truth. You just cannot control what you cannot see.
I mean, think about it. You literally cannot apply an access policy to a device that's invisible to you. It's just that simple. So, on a modern network, where most devices can't even run an agent, this makes agentless identification the absolute baseline. It's not a nice-to-have feature. It's a fundamental necessity. And this principle, it's the very core of what we call zero trust. This is a model where nothing is trusted by default. Every single device has to prove who it is before it gets access, and it doesn't matter where it's connecting from.
And when you apply this logic to the network, it's really straightforward. Step 1, identify every device. That has to happen first. Only then can you move to step 2, which is verifying its compliance. And finally, step 3, you grant it only the access it absolutely needs. It all starts with identification.
But, you know, if the logic is that simple, why do so many of these projects stall out or just completely fail? This next section gets into the number one reason: the harsh operational reality of the old-school enforcement standard, 802.1x.
So that standard is IEEE 802.1x. It's designed for what's called port-based control. That means a device has to authenticate itself directly at the network switch or the wireless access point before it's allowed to send even a single packet. And in theory, that sounds like the most secure model you could have.
But the operational reality? It's a whole different story. Documented analysis shows, and I'm quoting here, that 802.1x is costly and requires large-scale network configuration changes. And even worse, the constant need to manage exceptions creates significant management overhead, which leads to projects that drag on for months, sometimes even years.
So these challenges, they really fall into three main buckets. First, your switches have to support 802.1x, and that often means dealing with complex, vendor-specific settings. Second, like we've already said, all your IoT and OT gear just doesn't support it. And third, just managing the digital certificates you need creates its own set of persistent operational headaches.
And wow, this slide puts the scale of the problem right in front of you. The list of devices that actually support 802.1x, it's pretty short. The list of devices that need an exception, it's long, and it's growing every single day. The exception list isn't some small side task anymore. For a lot of organizations, it's the majority of their network.
Now, this workaround has a technical name. It's called MAB, or MAC Authentication Bypass. Basically, it uses a device's unique hardware address, like a password, to let it onto the network. But here's the catch. Every one of those entries is a manual exception that someone has to create and then manage forever. And that is the direct source of all that massive overhead.
Okay, so this is the most crucial point. While the project is stalled for months dealing with all these switch configs and MAB exception lists, what's happening? Unknown and unauthorized devices are just connecting to the network, day in and day out. The very security gap the project was supposed to close remains wide open.
So if that's what doesn't work, what's the alternative? This next section lays out a sequence that actually leads to success, and it's based on real-world deployment data, not just theory.
Well, the data shows a really clear failure pattern.
trying to do everything all at once. Projects that attempt to lock down the entire network from day one before they even have a complete inventory of what's on it, those are the ones that are destined to fail.
The sequence that works completely flips this around. First, you establish total visibility. See everything, your laptops, your IoT, your OT, without needing complex changes. Second, you analyze that data to actually understand what your network is made of. And only then, as a third step, do you select the right enforcement method for each part of your network based on that real data. And this is why flexibility is absolutely non-negotiable. See this number? 7. A modern NAC platform should offer multiple ways to enforce policy. The point isn't to use all of them, but it's about having the right tool for the right job and making that choice based on your data, not on a vendor's limitations.
Okay, this brings us to our final section. Let's distill all of this down into a few key questions you should be asking when you're looking at any NIC solution.
Question number 1, and this is probably the most critical. Can the platform just see and identify all your devices, especially the unmanaged ones, without forcing you to install an agent or reconfigure a single switch? Because if the answer is no, you are not going to achieve full visibility, period. And the final question is all about speed and getting value quickly. Can you actually start applying controls on your network as it exists today without having to kick off a 6-month or year-long project to reconfigure every piece of it? This is the key to avoiding one of those stalled projects we talked about.
So, we'll end on this one core principle. Enforcement has to follow the network data. You have to see your network first, then you can act. That's the sequence that works. Now, in our next explainer, we're going to break down those 7 specific enforcement methods you can use once you have all that data.